Okay, zero lie between that and that. I want to use transformation now. I want to use transformation. Okay, and they define a new variable. They define a new variable as this: u equal 3y minus 1. Please, I need you to pay attention. If I want to use a method of transformation, okay, here, I'm going to solve for y. Solve for y. Okay, solve for y. 3y equal to that implies y equal u plus 1 over 3. Okay, now I solve for y. When I solve for y, okay, I need a Jacobian. I'm going to differentiate this guy. Okay, the y to u. What is the y to u? 1 over 3. Okay, now then I need the absolute value of the Jacobian because we don't want negative. If it's negative, of course, this is still going to remain that. Okay, now my f of u that I'm looking for is actually going to be expressing y in terms of u multiplied by determinant of Jacobian. Please, I need you to pay attention right now. I want to find f of u. I have f of y. Okay, this guy is trying to tell me, okay, plug in, here, y equal to that. Okay, I'm going to plug it here wherever I see y, then multiply by determinant of Jacobian. If I want to finish that, it's going to be 2. What is y? Y is this guy. U plus 1 over 3 multiplied by that. You see that? What do I have? 2 into u plus 1 divided by 9. And let us see whether the result is going to be the same. Oh my God. Look at that. The result is the same. This is 2 over 9 into u plus 1. And this is also that. So the approach here is a method of transformation for one-to-one. Okay? Why the approach here is a method of distribution function. Is there any question on that? The two is going to give you the same result. Now, I just talked about the method of distribution function for one variable to one variable. And I just talked about the method of transformation function from one variable to one variable. We can also talk about, situation where we want to move from 2 variables to 2 variables, 3 variables to 3 variables. Now, that will take me to the next example. Take a look at example 2 right now. We consider the random variables y1, the proportional amount of gasoline stock at the beginning of a week, and y2, the proportional amount of gasoline sold during the week. Okay, now the joint density function of y1, y2 is given by this. Take a look at this. What you're given now, that's a joint, right? F of y1 comma y2 giving us that. Now the question now is find the probability of the density function y1 minus y2, okay, the proportional amount of gasoline remaining at the end of the week, okay? At the end of the week, use the density function of u to find the expected value of u. Let me tell you here, the moment you actually, if your f of u is wrongly determined, then the expected value of u will be wrong. Does that make sense? Now, here we have 2 variables, but we want to move from 2 variables to 1 variable. That is not going to be possible. You know what you're going to do? We need to create an artificial variable because we can only go from 2 to 2, 3 to 3. Does that make sense? Now, I want to use the method of distribution function now, and I need you to pay attention. How am I going to do it? Take a look at this. Using the method of distribution function, I'm only going to say that Why am I focusing on U? Because right now, if you take a look at this, we want to figure out the distribution of U, new variable. Your new variable depending on old variables, but this time around the old variables y1, y2. Now, using that, okay, if I want to use the law of complement, I can also rewrite that as that, isn't it? Law of complement, right? If this is less or equal to U, then 1 minus, that will be greater, okay? Now, what I'm going to do now is I want to talk about, take a look at this. Okay, let me first focus on this. What am I trying to tell the world? Y2 lie between 0 and y1 minus U. How? Please pay attention. I'm going to come here now. Take a look at this. Right? Y2 lie between 0 and y1, right? But I said something the other time. If you take a look at what I have here, y1 minus U. Y1, if you take a look at this, okay, if y2 lie between 0 and y1, okay, and what about y1? So if I actually want to redefine that, I'm actually telling the world here, take a look at this. This is for that. And for y1, the range of y1 is this guy. y1 u to 1. Let's say y1. Oh, sorry. Let's say y1 here. Y1. Take a look at this. You know, if I say y1 lie between y2 and that, then I'm trying to say this guy like a u. So that was why, if you take a look at what I have here, you're actually going to see that I said this. Let me clean up so that you can see. So this is for this, and for y1, that is the range. Whenever something like this come up, go ahead.
Why don't we just use y2 directly instead of using u?
Why do we? Because we're focusing. The random variable is u. If you take a look at what I have here, the random variable is u. So if you take a look at this, you know what does that mean? It's starting from u to something, right? U to what is the highest? 1. If you come back here, here, you can see the highest, right? The highest 1, right? Now, because we're using the idea of a greater than, okay, greater than u, we mean it's going to start from u, okay, and end in 1. Let me clear this one first. You understand that one now? Now, the remaining one, this guy here, you will start from 0. And when you start from 0, it's going to go, because this guy here is the range of y2. So y2 must depend on y1 as well. And not only that, depending on yu. If you look at that very restricted boundary. Now, the moment you have that, you do it sequentially. You first operate with this. Then after that, operating with the last one. Then finally, you're going to get this as your CDF. And the moment you get this as your CDF, don't forget the way we normally present it. We need to first present it this way. Don't forget. Then the moment I get my CDF, I'm just going to differentiate this guy. Differentiating this guy now. Then I'm going to have this. Okay? That is how to go about that. But you know what? I will do something now. If I don't want to, let's say, because of my time, maybe I can do that next time. Now, do you know the moment you get this, the moment you get this guy, then you can find the expected value of u. Expected value of u f of u du. But the moment this is wrong, this is going to be wrong. Does that make sense? Don't forget in the question asking this to find two things. Okay, find the density function of u to find expected value of u. Okay, now that's how to go about that one. Now I want to go into example 3. Okay, now is example 3. You have y equal y squared. Okay, I want to use the method of distribution function. Okay, what is my u? My u is y squared, right? You see that? My u is y squared. Now, if my u is y squared, okay, if you take a look at what I'm doing here, it means I want to figure out the probability of y squared less or equal to u. Whenever I get here, what am I going to do? I will solve for y. In solving for y, I'm going to have a square root. Okay? You know, a square root of u and negative u. Mathematically speaking, if you take a look at that, that can be interpreted as this. Is there any question? Because we're solving for y. Why am I solving for y? We're solving for y for us to be able to use a function of y. If we did not solve for y, there's no way. If I want to find probability associated with y, then I will not be able to use the density function of y. Now, right now, okay, I'm here. What do I want to find? I want to find the probability of y lie between a negative square root of u and a positive square root of u. If I want to do that, then I should be ready to do this. You see now? I'll be able to use this guy. That was why I was solving for y. And the boundary is going to go from that to that. Okay? And you remember what we did before. I said when you have a to b, f of s ds is the same thing as f of b minus f of a. This is a lowercase f, but these are uppercase f. That is what is playing out right now here. Okay? If you take a look at this now, okay, it's like after integrating a lowercase f, I'm going to get an uppercase. Then I'm going to plug in this, then I'm going to subtract, which is what we've done before. Any question about that? Any question? Okay, now if I have this guy now, okay, there's still something more to do. Okay, now if I have this guy now, I'm going to rewrite my CDF as this. Okay, then I need to differentiate. I want to differentiate this now. Because what am I looking for? I'm looking for f of u, a lowercase f of u. But right now, I got an uppercase f of u. And please, I need you to pay attention to how I'm going to do this. If I differentiate an uppercase f, it's going to give me a lowercase f. Then you're going to block. You're going to block that function. What do I want to do now? I want to differentiate square root of u. Square root of u is u raised to power half. Okay, now if you take a look at that, I got this equal square root of u minus negative that. Okay, now I want to differentiate this guy with respect to u. Okay, if you take a look at this is going to be small. Okay, you actually, which is that small f of that. Then block this. Differentiate this guy. This guy is the same thing as this. If I differentiate that, right? Differentiating that, which is, right? Which is, right? That was why you got this guy here. Okay? So which is going to be this now? 1 over this, you will come and do the same here. You come and do the same here. Okay? When you do the same here, you're going to get it. Don't forget, negative, negative will be a plus. So right now, I got this. So finally, my PDF is this. What did I just do? I factorized one of our school. I factorized this guy out. Also, I said it. Then I got this at the end of the day. Take a look at that. Okay. Now,